Good morning and once again welcome to my YouTube channel, Math with Ease by Mr. Kamotho. And in this video I want us to explain example 10 of graphs 8. And we are still looking at transformation. And this time we have actually looked at translation in the previous videos. Now we will start looking at stretch. And I want once again to explain my magic table. I call it Mayo. I call it Mayo table, where M is multiplication, A is addition, I is inside, O is outside, and minus A1 over A, and A. These are parameters of transformation. I will explain how. T is translation, S is stretch, V is vertical, and H is horizontal. Now, we are told that the graph of fx is the graph of x squared. And we all know the graph of x squared, we can actually plot it easily, because when x is minus 3, we must be having, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. This could be 1, 2, 3, 4, 5, 6, 7, 8, and 9. When x is minus 3 squared is 9, so we land there. That is the point. 2 squared is 4, minus negative 2 squared is 4. There we go, this is 4. Minus 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So we are kind of having this graph, very smooth graph. That is the graph we are having. And the graph we are having is y is equals to x squared. That is it. We have constructed that. Now draw y is equals to fx, and y is equals to 2fx. 2fx. And I want us to just look at it from the Mayo perspective. 2fx, you can see 2fx is a multiplication of the whole function fx. And it is not affecting the x, it is affecting the whole function. So this is multiplication outside. Outside means it's not within the bracket. We can see it's already now outside the bracket because it is affecting the whole function. If it was inside, then it would have been within the bracket together with x, but now it is outside. Let us see what happens in such a case. Y is equals to 2fx. Y is equals to 2fx. This is multiplication outside, and according to Mayo, let us say multiplication outside. According to Mayo, multiplication outside is a vertical stretch of scale factor 2. It is a vertical stretch of scale factor 2. What does that mean? This one is a vertical stretch of scale factor 2. A vertical stretch of scale factor A, because our A, you can already see our A is 2. 2 is actually the coefficient or the constant of the parameter of transformation. It is this 2 that determines how far or how much do we stretch our graph. So scale factor 2. Anything to do with scale factor, we have been told it is a multiplication outside. It means all y values, because of vertical, all y values are multiplied by the scale factor. All y values are multiplied by the scale factor 2. What does this mean? If you come now to this graph, if you come to this graph, our value of y here is 9. 9 times 2 becomes 18. I don't think we can get to 18. This is 10, 11, 12, 13, 14. So it's supposed to be up there. But that is not a problem, because we are going to see how is this explained using other points. You can already see the value of y here when x is -2, the value of y is 4. 4 times 2 is 8. So x remains -2, but now y becomes double of 4, which is 8. So we get it there. So this point is transformed there. The value of y here is 1. 1 times 2 is 2. The value of y here is 0. 0 times 2 is 0. The value of y here is 1 times 2, 2. The value of y here when x is 2 is 4. 4 times 2, another 8. It means now we have another graph that comes from far. It's connecting these new points. 0, 0 doesn't change. 0, 0 doesn't change. And you can see we have a graph that looks that way. And this is the graph of y is equals to 2fx. So the transformation is a stretch along, is a vertical stretch along the y-axis. Vertical stretch. You can see this point was here, but it has been translated or transformed to this particular point. So this is a stretch. Only y values are affected. X values remain the same. You can see this point again gets to this point. It's a stretch along the y-axis, and that is it. Part B of the question is talking of draw the graph of y is equals to a half fx. And now that we have understood this is also multiplication outside, so we will not explain that. We have explained it because it's affecting the whole function. Multiplication outside, as you can see again in our Mayo table, multiplication outside is a vertical stretch, again a vertical stretch of scale factor A. This A, you can see our A here is half. This is a vertical, this is a vertical stretch of scale factor a half. What does that mean? Anything to do with vertical, it will only affect all y values. Stretch it means multiplication by scale factor a half. It means therefore anything vertical or every value or coordinates of y is multiplied by a, which in this case our a is a half. Let us go back to the graph. It therefore follows that in the original graph, the blue one, which is y is equals to x squared, the y here is 9. 9 times a half is 4 and a half. 9 times a half is 4 and a half. So we go down 4 and a half and we land here. We land there. The value of y here is 4. 4 times a half is 2. There. The value of y here is 1. 1 times a half is a half. There we go. 0 doesn't change because 0 times half remains 0. But y here is 1 times a half, we land on a half. Y here is 4 times a half, we get 2. Y here is 9 times 2, we get what? We get 4 and a half. If we were talking of 4, if we had 4 here, for example, 4 squared would have been 16, and 16 times a half is going to be 8 for this particular graph. So we are going to land there. 4 is 8. The same case would happen if we had minus 4 here, minus 4 here. Minus 4 squared would have been 16. But now 16 divided by 2 would have been 8. So we can easily say our graph extends there. So the graph now we have is looking like the curve which looks more spread. And there we go. That is the graph of y is equals to a half fx. And by that explanation, we have explained stretch along the y-axis with a very simple table. I call it my magic table, Mayo table. Get this, understand it. It will help you to transform every kind of graph or a curve. Thank you. Let us meet in the next video.